Now that we're in the probability chapter, there's a lot more calculations than what we've done up to this point. So the probability chapter, since probability is a field in mathematics, we are going to have to do some calculations to help us understand how likely something is to happen. So let's start with just a few definitions. A probability is a number between 0 and 1. And it represents or reflects the likelihood of occurrence of some outcome. Now, even though it's between 0 and 1, the probability equaling 0 specifically means that the event cannot happen. It is impossible for that event to happen. Now, on the other hand, a probability of 1 means that it is absolutely certain for the event to happen. There are very few things that would have a probability absolutely equal to 0. We'll have some probabilities in this course that are going to be tiny. The probability of winning the lottery is something, like that. I can't remember. It depends on the game that you're playing, but the probability of winning the lottery is really, really, really small. So that is approximately 0, but it's not 0. It is possible to win the lottery. It's just not very likely. So on that same example, it is possible for nobody to win the lottery unless they have purchased every single possible combination of numbers. So in that case, if you have purchased every possible outcome, then the probability of winning would be 1. But there's very few things that are absolutely certain to happen. Now, when we talk about probabilities, there are two types of probabilities that we have encountered just in our everyday lives. A lot of the probabilities that you've encountered have been subjective interpretation. That's just a personal measure of strength or belief. So if I wanted to know the probability of it raining today, well, that is somewhat subjective if I just look up in the sky and see how many clouds there are. I have not studied meteorology. I'm not looking at a model. Now, a meteorologist is making a little bit more of an informed decision, but in some ways they still are having to do some subjective interpretation. They certainly have experience, but it's difficult to talk about things like weather when dealing with probability. On the other hand, most of what we're going to be doing in this course is this objective interpretation. So often we'll look at the relative frequency, which is looking in the past at how often something has occurred. And that helps us describe the long-term proportion of the time that an outcome will occur. So if you flip a coin 1,000 times and you get 700 heads, then you're probably looking at a biased coin. So objective interpretation is what I want us to focus on for the rest of this chapter. Now, the notation that you'll see is usually a capital P, and then in parentheses, whatever the outcome is that you're interested in. So you can interpret this as the proportion of the time that the outcome occurs in the long run. The definition where probability, or the interpretation rather, that probability is the proportion of the time that the outcome occurs in the long run can be demonstrated nicely in StatCrunch. So I've gone to this applet, and it's the simulation applet, and there's a couple of different things here that you'll be using some of them for this week's StatCrunch lab. But I did the coin flipping, and I made it a fair coin. And I want to look at how many heads that I'll get when I flip the coin. So I flip the coin and I have tails. So right now, I've gotten no heads, and so therefore the proportion is actually 0. So my probability here doesn't line up. I should have had half of my occurrences heads and half of them tails, but I only had this one outcome and it didn't happen. If I run it again, now I got heads, and right now, for the moment, it is a 0.5 probability. That doesn't necessarily happen. That could have just as easily been another tails. But as I keep running, what you notice is I keep getting new outcomes and my proportion is changing. Now I'm going to speed this up a little bit and do 5 at a time. So you can see what's happening. If it's heads, it's red. If it's tails, it's black. And the proportion of heads right now is only 0.375. So we understand the probability of getting a head as being 0.5. But in the short term, that just isn't happening. It's not like you flip a coin and it's heads and then tails and then heads and then tails. You might have 6 heads in a row. It's not likely, but it is impossible. It's not likely, but it is possible. So if I keep doing this and I keep running, I see what's happening. I'm not at 0.5. I'm at 0.5385. And for a second, I was at 0.5 again. But you see it's actually changing quite a bit. Now, this graph here, this convergence graph, what it's doing is it's plotting what the current proportion was for the proportion of heads. And you can see that it varies a good bit here in the beginning. But watch what happens when I run 1,000 runs. Notice that the proportion now is 0.5108. And then look at this convergence graph. So the first part right here is what we saw zoomed in. Now we've done over 1,000 runs, so we have to zoom out a little bit. But notice that there was a lot of variation there at the beginning. And then there was this period of time where it goes up and it kind of goes back down. But then eventually it starts really flattening out. It doesn't seem to be fluctuating a whole lot. You're looking at the proportion. So in the long run, I'm getting close to 0.5. And if I keep doing this, I'm up to 6,000 cases, you can see that I'm floating there pretty close to 0.5, but I'm not there yet. So probability, even though we understand what the theoretical probability is, I want you to recognize that the empirical probability, what actually happens when you run these trials, is not always going to be equal to the theoretical probability. But in the long run, it's going to get really, really close. So that's actually our next little section in the notes, this law of large numbers. That's what you saw with that applet. As the number of observations increases, the proportion of the time that an outcome occurs gets close to the actual value of the probability of that outcome. We could do the same thing with rolling a die. It should be a 1 in 6 chance of getting any particular number, but you're not going to see that proportion right away. It's going to fluctuate a good bit. But as the number of observations increases, where you've done thousands and thousands and hundreds of thousands of events, you're going to see the proportion getting closer to the actual value of the true probability. So a few properties here. The probability of any outcome is just a number between 0 and 1. You can't have a negative probability, and you can't have a probability greater than 1. You have either some value that's 0 up through 100%, but you can't have more than that. If outcomes can't occur at the same time, then the probability that any one of them will occur is actually the sum of the individual probabilities. You flip a coin, it's either heads or tails. You can't be both at the same time. But the probability that you get either heads or tails, well, that'll just be 1 because you have to get something. And then finally, the probability that an outcome will not occur is equal to 1 minus the probability that the event will occur. So think about that. The probability that something will not occur is equal to 1 minus the probability that it will occur. An event either occurs or doesn't occur, no matter what the probabilities are. So let's say that I want to roll a 3 or a 6. Well, my probability of that happening is 2 out of 6, because that's 2 possibilities out of the total 6. If I want to know the probability of not a 3 or a 6, well, that's everything else. That's getting a 1, a 2, a 4, or a 5. So that's 4 out of the 6 outcomes. Well, you can see here that these 2 events make up the entire, what's called the sample space. But these 2 events, it either occurs or it doesn't occur. And the mathematical relationship here is you would subtract 1 minus the probability that the event occurs.